Hello everyone, we are back. We are doing a quick tutorial still on two-factor ANOVA. This one will be using an ANOVA source table. So this is the same practice problem that we have our other quick tutorial on. It's the same practice problem from class, but I'm going to show you a kind of a different way to do it. So instead of, say, I gave you all of this information and I gave you the information about the means and the t's and all of these different information, what if I gave you part of the way, but I gave you an ANOVA source table to complete instead? One of the reasons that I like this kind of problem is because it allows you to answer the questions pretty quickly, and you can still show me that you understand the relationship between these formulas and what sums of squared and degrees of freedom and how they influence mean squared and how which mean squared together works for this F ratio, etc., etc. So this is a little bit easier, a little bit quicker way to do it. There is a skosh more algebra in it, but I think ultimately you'll feel really comfortable with this once we practice. So the place that I always like to start is I like to start with my degrees of freedom because I have that information here. So I have 30 participants, in total, which is my n. I have my little n is here, is equal to 5. I have my conditions. It's a 2x3 design, so that means my k is equal to 6. I know it's a 2x3 design because I have 2 levels of light and 3 levels of tempo. So again, the place that I like to start is with those degrees of freedom. Degrees of freedom total has already been calculated for us. Truthfully, I could have this degrees of freedom completely empty, and this has enough information to fill it all in for us. But again, some of these have already been done for us just to kind of make it a little bit easier. So what we have here are degrees of freedom between treatments. If you remember, degrees of freedom between treatments is k minus 1. So we have 6 conditions minus 1. Our degrees of freedom between treatments is 5. If we want to do our degrees of freedom within, I could take my 29 and I could subtract my 5, and that would give me 24 here. Or I can, oops, sorry, too far. I can use my formula n minus k. N here is 30, my k is 6. I still get 24. Now let's move on to step 2, degrees of freedom. Our light has 2 levels, so 2 minus 1 is equal to 1. Our tempo has 3 levels. They've already solved that for us. But again, 3 minus 1 is equal to 2. And how we get this interaction degrees of freedom, remember we're going to take this between value and then we're going to subtract out both of these values. So we would take our 5 minus 1 minus 2, that will equal 2. So we have our degrees of freedom for all of them now. The next place that I like to look at is kind of what do we have for F? Again, how different problems are set up. You may need to start in different places to kind of figure out how these all work together. But here I have 2 F ratios are given to me. So I have my F ratio for these, and I don't have my F ratio for tempo. But I have everything I need for my F ratio for tempo. If you remember, F is equal to mean squared for the factor divided by mean squared within. So I have mean squared for the factor, I have mean squared within. So all I'm going to need to do there is do that math. 30.84 divided by 5.42 is 5.69. Now, just like I did use this formula to find my F, I can go back, right? So now I'm looking for the mean square of what this factor is, right? I want to know what this value is right here. Well, this is this value right here. And I have mean squared within, and I have my F. So I can just multiply my 5.42 and my 5.53 to get this value here, and that's 29.98. Notice from the other quick tutorial that those calculations are slightly different, right? It's not a rounding error. It's because we rounded differently going between, going kind of across, dividing versus multiplying. And so it wouldn't be considered a rounding error here. Your assignment will be set up to have the rounding done from this problem. We'll do the same thing to get this value here. Our mean square of interaction, we're gonna multiply our 9.69, sorry, my Apple Pencil just died, and we're gonna multiply that times our 5.42. When we do that multiplication, we're going to get 52.52. So again, we did that by multiplying our 9.69 times that 5.42. So now that we have our F, our mean squared, our degrees of freedom, we can go back and get those sums of squared. So if you remember correctly, the way that this worked is we said, okay, sums of squared, but divided by degrees of freedom is equal to mean squared. So here I have the mean squared and I have the degrees of freedom. So to get that sums of squared, I'm going to multiply those two. So what I'm going to do is I'm going to take my 29.98, multiply it by my 1, and I get, yay, happy math, 29.98. I'm going to do the same thing here, 52.52 times 2. When I do that calculation, I'm going to get 105.04. Again, I used this value multiplied by this value, and I got the 105.04. Now I have all of those values, and if you can check your work and see that we're roughly going to be that 196.67. If we're slightly different, again, that's going to be a function of rounding. We still need to get our mean squared, our sums of squared within. And again, I can do the same thing. I can take my 5.42, I can multiply it by my 24, and I get 130.08. So when I've done that, the only thing that I have left then is this total formula at the bottom. Remember, our between treatments plus our within treatments is equal to our total. So I'll just add this 196.67 plus this 130.08 together, and I get 326.75. So that's how we finish that ANOVA source table. Again, once this is completed, I have everything I need for my 6 steps of hypothesis testing. I have my degrees of freedom, I have my Fs, I have everything I need to write an F statement. I have my degrees of freedom to figure out that comparison distribution, to figure out those critical values. I have my Fs to evaluate based on those critical values. But the math is a lot easier and a lot quicker. So again, this is why I'm interested in you being able to do it from this direction, because it saves time but still shows me your understanding of these formulas. Thanks so much.